Okay, in this problem, there's a train that goes along for 80 miles and travels that 80 miles in 2 hours. And it's supposed to go 125 miles total, and it's supposed to get there by 4:30. So that means there's half an hour left for that last part, and the acceleration is going to be 120 miles per hour squared during that last half hour. So we're supposed to figure out if the train's going to make it to the station on time. And here's a partial solution that was written, and you were asked to figure out what things are incorrect in here. So there's a few problems. We'll start by saying that the student who wrote this, I'm kidding, it was me, but I was pretending that I was a student and making some of the errors that I've seen before. One thing that wasn't done was, this is a yes-no question. Will it make it to the station on time? Whenever you see a yes-no question, you should restate the question. And so let's think about how we could calculate this and what we could compare. We want the train to have made it 125 miles or more during that time. And so what we could do is we could eliminate that as a known, and we could say, did the train travel 125 miles or more by 4:30? So we could say x is our symbol. Is that greater than or equal to 125 miles? And then another mistake that was made here was a mistake of an error of omission, which is not figuring out what it is you wanted to solve for. So x is the thing that we want to solve for. When we have a yes-no question, we have to pick some piece of information that we're not going to use in our calculations, and then we're going to use it as a comparison. So x is that value. We expect it to come out to a positive value, and we expect it to have units of meters. So here was a possible equation that could be used, but no indication as far as what was known and unknown. And then you look down here, and they started executing the plan. How many unknowns are in that equation? 0. That's a bad sign. You should not have 0 unknowns in an equation. Okay, too many unknowns is bad, but just as bad as having 0 unknowns. And so this is an unknown. We're going to treat that as an unknown, and we know all these other things. So don't forget to add your checks and question marks in your solution. All right, so x is the unknown, and we can go ahead and solve here, except there's one more mistake. Did you catch it? Up here, the train was traveling at a constant velocity for 2 hours and went 80 miles in 2 hours. So that means all during this time, the train was traveling at 40 miles per hour. And we can call that V naught x. Okay, so that's not really part of my plan per se, but it really does come into play in my planning. So this is 40 miles per hour instead of 0. And now this is x instead of being a known value. And you might have been thinking, hey, you forgot to convert things. Well, this is a case where you could convert it, but it turns out to be faster if we don't convert. We can do everything in miles. So we can say x equals 80 miles. Now I don't use the abbreviation m for mile since we use that for meters, although in our familiar MPH there is the m abbreviation for miles, which can be confusing. So I'm going to write it out as miles per hour times 0.5 hours. So we see that we don't need to convert because our units are going to work out and give us units of miles here. And then we have plus 1/2 times 120, and this is already written in the appropriate format, miles per hour squared, 0.5 hours. Notice the squared is outside the parentheses, so that's going to square the number and the unit. So we're going to have hours squared canceling with hours squared, and that will give us units of miles. So miles plus miles plus miles. When you're adding and subtracting, everything has to have the same units. And we plug these values in, and we get 115 miles. And so that's not our answer. Okay? Sometimes we get caught up and we think, okay, we finally got a number out of our calculator and we think the problem's over. But is the solution complete? Well, no. So we have to finish that. So I started to write it. So since x is less than 125 miles, you can say, no, the train did not make it by 4:30. Okay, and that was assuming that the train just kept speeding up for that entire half hour. If it was truly going to be successful, it would have to have a slowdown period as well. But even without allowing any time to slow down, it still came up 10 miles short of its goal. So now we have a complete solution. The units all made sense. We checked that. It did come out to be a positive number. The magnitude was reasonable. It was in the ballpark of what we expected it to be, but it just came up a little bit short.